Okay, so here we have a problem that is a little bit less trivial than the one that we just did. So here we're being asked to prove that this particular equation, so x cubed plus x minus 1 equals 0, has exactly one real root. And so we want to do this without just using a graphing calculator or something like that. We can actually use Rolle's theorem to help us prove that this function or this equation has only one real root. So what we have to do is we will first prove that it has a root by using the intermediate value theorem. So let me actually write this out. So we will use the intermediate value theorem to show it has at least one root. So remember that the intermediate value theorem will only tell us that there exists at least one root, and it doesn't tell us how many there are, and it doesn't tell us where it occurs. We actually still don't need to know where it occurs to do this problem. So we're going to first use the intermediate value theorem, and then we'll use Rolle's theorem that we just defined or wrote down. Maybe I'll write this up. Okay. So theorem, and that will tell us that there can only be one. Okay, so like I said, we will use the intermediate value theorem, so this is a good review of that as well. So we'll let our function be equal to the left-hand side, so x cubed plus x minus 1, right? And this is a continuous function. F is continuous, it's just a polynomial. This time we're not given an interval in which the root might exist. So we actually have to try to pick numbers where the function is going to be negative, and then pick another number where the function is going to be positive, and then if we find two of those, knowing that the function is continuous, it will have to pass through 0. Right? So the idea is find some numbers a and b such that f is negative at one of them and positive at another, and then we know that a continuous function will have to pass through 0, like right here, in order for this to be the case, right? Okay, so what we can do is try minus 1. That will give us negative 1 minus 1 minus 1. So this is negative 3, which is less than 0. And if we plug in 1, we'll get 1 plus 1 minus 1. So this is 1. And so we have found our two values where we get either a negative number or a positive number. So we can say by the intermediate value theorem, there exists a point C, I'll say a number C somewhere in the interval minus 1 to 1, such that f of c equals 0. Okay, so that was this first piece here, and now we need to use Rolle's theorem to show that there can only be one root, right? Okay, so how we're going to go about doing this is basically we will assume that, so we'll ask ourselves, what would happen if there were two roots? So what if f had two roots, and we'll just call them a and b, okay? So that would mean that both f of a equals 0 and f of b equals 0, right? So the idea is that we will just assume that this is the case and then follow the logic, apply Rolle's theorem, and then come to some contradiction or some statement that doesn't make any sense, and then we'll follow that back to just say that, well, that can't be the case, that f has two roots, because we got to a contradiction. Okay, so that's how we're going to approach this. So we assume this is the case. Now notice that f of a and f of b are equal since they're both equal to 0. So that gives us the third condition in Rolle's theorem. So I'm just going to scroll back so we can look at these. So that was the third condition we needed to apply this on the interval a to b. We also need the f is continuous and differentiable on that interval, but we know that f is continuous and differentiable on the whole real line. So we're fine on the interval a to b. Okay, so we can apply Rolle's theorem. So applying Rolle's theorem, we've already used the number c, so I'm going to use the letter c, so I'm going to use the letter d to in this statement. So there exists a number d in the interval a to b, such that the derivative f prime evaluated d is equal to 0. So that's the conclusion, right? And so what we can do now is actually compute f prime, because we have the actual equation for the function, right? So if we compute this just using the power rule, this is 3x squared plus 1, that's the derivative, right? But notice that this is never going to be 0, right? So this is a quadratic function that is facing upwards, and it never is equal to 0. It's always greater than 0, right? So what that means is that we can't have the existence of such a number d. So there is no d in the interval a to b where f prime of d is equal to 0, because as we see from the equation for f prime, it can never be equal to 0. Okay, so this is a contradiction. So we cannot have such a number d. And that means that, sorry, that was the wrong conclusion. We cannot have such a number d, and the conclusion is that we cannot have two roots, a and b. There should only be one. Okay. And so that is how we approach this problem. Okay. And I think we will talk about the mean value theorem in the next video.